All right, our first lecture is going to be about the difference between distance and displacement. All right, and in order to do that, we need to create a new definition. And the definition, or a new, not definition, but we need to define a couple of terms. The first one is vector, and the other one is scalar. Okay, and we'll start with scalar, where a scalar is something that can be measured. Something that can be measured in a quantity. In a quantity only. Okay, a scalar is something that is measured in a quantity only, and you'll understand what I mean by that here in a sec. Because a vector requires a magnitude or a quantity okay, or you can think of it as size but it also requires a direction. And this is the important part. Whenever we have a vector, whenever we're talking about something that is a vector, it must have a magnitude and a direction. It must have a size or a length or a certain amount, and it has to be in a particular direction. And that is a crucial distinction between a scalar and a vector. Okay, and so we have these terms that we're going to be dealing with here. Okay, and the first one, and so we have these particular terms. Let me give them to you guys. So it's position, displacement, distance, rate, speed, velocity, and acceleration. All right, these are the terms that we're dealing with here. Now, we're going to put them into, or we're going to separate them into two categories. And some of these are just amounts. And others of these require, and they have an amount, but they also have a direction. Okay, and you just kind of need to memorize these. So the ones that are our scalars, okay, I'm going to circle in red. Okay, and that would be distance, and rate, and speed. Okay, and the other three, circling in blue, the other four circling in blue, are position, displacement, velocity, and acceleration. Okay, and they kind of come in pairs. Position is by itself. Okay, it is a vector, and it just says where something is in relation to something else. And normally, that particular position is, it is a vector, but it's not a particular distance. But we measure positions by determining a displacement. All right, and so we are going to, we're going to show this graphically here. So we're going to draw a number line. Actually, let me redo that. I can do better than that. There we go, number line. And on our number line, we're going to have a 0 point. All right, so that's going to be 5, and this is going to be -5 over here. Okay, so what we are looking for, okay, let's say that the position we are at is here. Okay, this position would be 3. Okay, but what distinguishes it from, say, this position over here okay, where are you? That position here, because this is also 3, right? That's 3, and that's 3. The difference is this is a -3, okay, and that negative, okay, implies a direction, and that's why our position is a vector, because it's in a particular direction. Now, if we were to go from 0 to 3, now all of a sudden we have this arrow right here, and this arrow represents a displacement. Okay, and our displacement is measured determined by our final position minus our initial position. And that's it. But it's always final minus initial. Okay, another way of writing this is our change in position, or delta x. And you guys have seen this before, seen delta before when you start dealing with slope. All right. So now all of a sudden we can show how moving from 0 to 3, or moving from 0 to -3, is a different quantity. It's a different amount, and it is a vector because it implies a direction. Okay. However, if we're just looking how far did something travel if it goes from 0 to 3 or from 0 to -3, now we're looking at distance. Okay. And our distance is the absolute value of our displacement, or how far it went. That's it. It's not, going from 0 to 3, the distance between 0 to 3 is equal to the distance from 0 to -3. Okay, but we're not worried about, if we just want to see how far you went, then that negative doesn't matter. Okay, so, so that's the difference between displacement and distance. And remember, displacement is a vector. Oh, I color-coded them wrong, sorry. Displacement is a vector, and distance is a scalar. Okay. That really should be sufficient. Well, actually, no, we'll define the other ones. All right, velocity is similar to that. We have two different definitions. We have speed, and we have velocity. And these two are pretty much the same thing, except velocity is speed in a direction, and speed is how fast. All right, and this is where we can bring in our new definition of rate. Okay, velocity equals the rate of displacement. Speed is the rate of change of distance. And then acceleration is the rate of change of velocity, and we will get to that at another time. So this is our quick and dirty lecture on distance and displacement and speed and velocity. We will cover it more later, but this is what you need for tonight's homework. So it's B-Dog signing off.